In this video, we'll review how to compute the expected value of a random variable. So here's an example. We have a random variable x with the distribution defined as follows. So this is a continuous value that takes on a value between 0 and 1. And we have this function f of x equals 1 of x. And so we want to know the expected value of this random variable f of x, or in other words, compute this quantity. First of all, we can verify that this probability distribution is indeed a probability distribution. It should be fairly straightforward to see that this quantity is always greater than or equal to 0, so it suffices to compute this integral. And we hope that this integral will evaluate to 1. So let's see. So the integral of 0 to 1, 3x squared dx, well, that's just going to be x cubed, and we want to evaluate that at the endpoints 0 and 1, and that should give us 1 minus 0, which is 1. So this is indeed a probability distribution. So let's review the idea of expectation. So the definition of the expected value. So the expected value of a random variable x is defined like this. We sum over all the possible value of that random variable, and we take the product x times the probability that the random variable has that value. If x is continuous, then we have the analogous definition here, where instead of a summation, we have an integral. So the expected value of x, or the mean of x, is a measure of the central tendency of our random variable. The expected value of f of x is similar. So just missing f here, but really instead of x here, we're just putting in f of x. So let's look at an example. Let's say we have a random variable x with this distribution. So p of x is 1 for x between 0 and 1. And again, we can verify that this is indeed a probability distribution. 1 is greater than or equal to 0, so that's good. So we just need this integral to evaluate to 1, and it does. So the integral, so this is going to be x evaluated at these two endpoints, or 1 minus 0, which is 1. So let's say we also have this function, f of x equals to e to the x, and we want to compute the expected value of f of x, or e to the x. Well, that's just going to be, as we saw in the previous slide, 0 to 1, e to the x, probability that my x is takes on this quantity, dx, and this is going to just be e to the x times 1 dx, which we know is just e to the x evaluated at my two endpoints. So I get the expected value e minus 1, or e to the 1 minus e to the 0. So e to the power of 1, that's just e to the power of 0, that's just 1.